So these are going to be the notes for sections 12.3 to 12.5 that are for the class that would have happened on Wednesday, October 19th. So section 12.3, we're continuing with the exponent rules that we started looking at a lot of exponent rules in sections 12.1 and 12.2 on Monday's class when we met in person. And so that's where this is number 6. This is exponent rule number 6, where we did numbers 1 through 5 on Monday in class. So if y'all haven't already done so, go ahead and make sure that you get out your 12.3 to 12.5 fill in the blank notes that I gave you when we were in person. If you did not get those notes in person, you can also go to the email that I sent out to the class and you can print these out for yourself and fill them in as we go. You will have a quiz at the end of the day that you'll be filling out on your own to turn in when we return to class. You will also not get this material in person in class. This is the lesson that you need to watch online in full to make sure you understand it, and then you will be tested on the material when we return to class. So make sure that you are paying attention. And if you have any questions that you need to ask in person, you can go to the Fort Walton Beach Math Lab in room 702 at the Fort Walton campus to ask any questions in person. We will have a review day when I get back to class on Monday, and then you will test the following Wednesday, a week from the 19th. So let's go ahead and get started. Hopefully everyone has their notes by now. So rule number 6 here. It says a to the 0 power equals 1. What that says is that any value, whether that a is a number or a letter, anything to the 0 power is always equal to 1. A lot of students are interested in the proof for this rule, so if I'm showing you the proof for this rule of a to the 0 power equals 1, I'm going to show you by using an example why this works, because a lot of students want to see that. So if I use an example such as a squared over a squared, and we decide to simplify that. Well, one way to simplify that is to think about that any value divided by itself always reduces out to 1. That this can reduce to 1 value. You can think of that as a squared was a times a over a squared is a times a, and each of them reduce out to 1, and 1 times 1 is still 1. Another way you can think about this is a squared divided by a squared is if you recall the exponent rules that we used on Monday, where you divide the exact same base, you are allowed to subtract their exponents to reduce. And so if we use that rule, we'd say, okay, the base a, we start with the exponent on top, and we subtract the bottom. So 2 minus 2. When we simplify that, you'll get a to the 0 power. And that's where we would have to stop at this point until you get to this rule. But what we have to conclude is that if both of these values that we ended with started with the exact same starting problem, and each of them were worked mathematically in a correct fashion to get to the ending result, then what we have to conclude is that these two ending results are equivalent, that 1 and a to the 0 power are equal. So we can conclude that any value, whether that's a number or a variable, to the 0 power is always 1. Now, rule number 7 is a to the first power. Any value raised to the first power is always itself, or a. So, looking down to the examples that we have here, for part A, we have negative 11 to the 0 power. Because the negative 11 is in the parentheses, the 0 power applies to the entire parentheses. And so we get to conclude that this value, since it's raised to the 0 power, is 1. In example B, we just have x to the 0 power. Since it's raised to the 0 power, the answer is 1. In example C, you have a number, 712 all raised to the first power. Well, anything to a power of 1 is just itself. So we call that 712. But the 712 is considered the more simplified answer since it doesn't have the written exponent of 1. Now in part D, example D, we have negative 8 to the 0 power, but there's no parentheses. So if you think back to when we talked about exponent rules in general, exponents only apply to what they're directly next to. And so in this case, the 0 is only directly next to the 8 and not the negative. And so the negative comes down or continues in the problem, and the 8 to the 0 power, anything to the 0 power is 1. And so we end up with negative 1 is our answer here. For example E, the 0 power only applies to the y, and the negative 3 continues in the problem. And so the negative 3 comes down, y to the 0 power is 1, and then fully simplifying negative 3 times 1 gives us negative 3 for our final answer. So that goes through rules number 6 and 7 of any value to a 0 power and any value to the first power. If we continue on in the notes, we're going to look at a rule that has to do with negative integers as exponents. So for the development of this rule for rule number 8, I want us to look at this example that I've given on the notes, where it says d to the second power divided by d to the fifth power. So if we write that out a little bit more in depth, then what we can do is say on top we have d times d. That's how we can write out d squared. And on the bottom, we have d times d times d times d times d for d to the fifth power. And then, if I reduce d over d one time is 1, d over d a second time is 1, and I have no more d's on top to reduce with the ones on the bottom. So what I have here is now 1 times 1 on top is 1, and on the bottom I have d times d times d, or 1 over d cubed. Okay, so we know that mathematically that is correct. That is an answer. But if I did d squared over d to the fifth and started again and started using the rule from last class where we can subtract exponents when we divide, then I would do d to the second power, since that's on top, minus 5, since that is the exponent on the bottom. And I would come up with d to the negative 3 power when I do that. And as of last class, this was as far as we could have gotten. However, what we can conclude now is that if we started with d squared over d to the fifth in both of these ways of working this out, that we then work them correctly mathematically both ways, we have to conclude that these two are equivalent answers, just written in a little bit different format, but that they represent the same value. And so if you notice, the only difference there is that in the bottom one, we have d with a negative 3 power when it's on top, and in the top, we have a fraction where we have d with a 3 power that's now positive when it's on the bottom of the fraction. And so what this leads to is that we have this rule about bases with positive or negative exponents, and it just varies which side of the fraction, whether it's on the top or the bottom, for if a exponent is positive or negative. And so this leads into rule number 8 here, that if you have a base with a negative exponent, what you're filling in is that this is equivalent to a fraction where you now have 1 on top, and you can flip that value of a to the negative n to the bottom to make it a to the positive n. Conversely, if you started, with 1 over a to the negative n power, so your negative exponent's on the bottom, to make it positive, we flip it over to the top. So we now have a to the positive n power on top. So it just depends on where your negative exponent is, and then you flip it to get a positive exponent. Simplifying means to write answers with all positive exponents, unless otherwise noted. So from now on, if you end a problem with a negative exponent, that is incorrect until you change that to make it a positive exponent in your final answer. So we're going to have problems that ask us to express with positive exponents and simplify. So for this first one, x to the negative 3, we just want to make it positive. So since negative 3 had the value of x on top, we're going to flip this over to the bottom of a fraction, that we now have 1 over x, and we've changed the exponent to be positive 3. And that's our answer. In b, we have a value a with a negative exponent on the bottom, so to make it positive, we are going to flip that negative exponent up to the top. So this is now a to the positive 7, and there's nothing else to do. That's our answer. Now in C and D, we end up with a little bit more work. They're a little bit bigger problems. You're only supposed to flip bases that have negative exponents. If any base has a positive exponent, you leave it where it is in the fraction. And so in C, the 2 has an implied exponent of positive 1, so it stays where it is. But the x to the negative 3, that's a negative exponent, so we want to now flip it to the bottom of the fraction to make it positive. The y has an implied exponent of positive 1, so it stays where it is on the bottom of the fraction. But the z to the negative 6 has a negative exponent, so we want to flip it to the top to make it positive. So when I do this flipping, I now end up with 2 still on top, z now to the positive 6 on top, and on the bottom, y is still there, but we also have x to the positive 3 power now. All of our exponents are positive, and there's no like bases that we can use to combine any further, and so this is our answer. For D, 3 to the negative 3 power, since it has a negative exponent, our first step is to flip the 3 to the now positive 3 power if it's on the bottom. And now, to fully simplify, since this is a number, we actually want to go through and multiply that out. So on the bottom, we have 3 times 3 times 3. So this fraction is 1 over 3 times 3 times 3. And now you just have to multiply the bottom. So 3 times 3 is 9, times another 3 is 27. But remember, that's on the bottom of our fraction. So your final answer is 1 over 27. Okay, going to the next page on your fill-in-the-blank notes. For E, your example problem is 2/3. This is to the negative 2nd exponent. And so applying this is now 2 to the negative 2 power over 3 to the negative 2 power. Since last class we talked about how you have a quotient in parentheses with an exponent, the exponent applies to both the top and the bottom. And since now we have a top and bottom that each have negative exponents, we are effectively going to switch their positions to make their exponents positive. So I'll now have 3 to the positive 2 power on top and 2 to the positive 2 power on the bottom, since I wanted to make those exponents positive. And now your last step is to finish by simplifying those numbers. 3 squared, 3 times 3 is 9 on top, and 2 squared, 2 times 2 is 4 on the bottom. So your answer is 9 over 4. If that turned into a fraction that could simplify further, you would need to simplify it further. Now what I've put into your notes here is just a summary of rules now that you have the information about zero exponents and negative exponents. So this is going to review some of the information that we did on Monday, but put it all together. And so for part A here, y to the negative fourth times y to the negative second times y cubed. Remember that when you're multiplying the same base, this capital Y is supposed to be a lowercase y. My computer must have automatically capitalized it. But when you multiply the exact same base, you add their exponents. So this is now y to the negative 4 power plus the negative 2 power plus 3. In adding those up now, we have y to the negative 6 plus 3, and that simplifies to y to the negative 3 power. However, you're not allowed to end with a negative exponent. And so your final step should be, since that was negative, that we now flip the y to the bottom of the fraction and make the exponent a positive 3. And that is your answer, 1 over y cubed. For part B here, there's a few ways you can work it. If you want to flip the exponents to make them positive first, that's fine. If you want to skip the step of making them positive first, you can work with them negative, which I'm about to show you, as long as you appropriately use your division rules for exponents. That if we have the same base being divided, you need to recall that we're going to subtract the exponents. And so we subtract from the top so that I can stay on top. I have x to the negative 3 power. I subtract for the rule, but what happens is I'm subtracting a negative 8 for this particular problem. And then what ends up is I have a double negative there, and this double negative in the middle ends up changing to a plus. So we end up with x to the negative 3 plus 8, which gives us x to the positive 5 power for our simplified answer. For problem C, we're now doing the exact same rule as we did in problem B, since we are dividing, but we just now have two like bases that we're doing. So we have a to the 7 minus a minus 2, since we're subtracting exponents when we divide like bases. And we have b to the 6 minus 4 power. For the a, this minus minus becomes a plus. And so a to the 7 plus 2 gives us a to the 9th power, and b to the 6 minus 4 is b to the 2nd power. And now you're not allowed to combine those any further, since a and b are different bases. You cannot combine their exponents. So that is their final answer here. For D, we're multiplying two monomials here. And so we're going to multiply their coefficients. 7 times 3 is 21. And then for the like bases, we're going to add their exponents since we're multiplying. So we have x to the negative 6 plus 8. And then y, this y in here has an implied exponent of 1. So it's 1 plus a negative 4. So this gives me 21x to the positive 2, y to the negative 3. And now the exponents are combined correctly, but we have to finish by flipping that y to the bottom since it had a negative exponent. So your final answer is 21x squared on top over y to the positive 3 power on the bottom. For E, we're going to be dividing, but I'm going to notice that I have this x to the 0 power. Remember that anything to the 0 power automatically reduces to 1. And then I'm also going to notice I have just y and y, top and bottom. They're exactly the same. They are also going to reduce to 1. And so I now have negative 30 over 15 for my coefficients, times 1 for x to the 0, times 1 for y divided by y, times z cubed minus 2, since we are dividing z cubed divided by z squared. So this gives me negative 2 times 1 times z to the first power, which is just z. So when I multiply all this, I end up with negative 2z. Notice that you can end with a negative coefficient, you just cannot end with a negative exponent. For f, recall from last class that one base raised to 2 exponents means you multiply the exponents. So this is x to the negative 3 times 7, which gives us x to the negative 21 power. To fully finish for positive exponents, we now flip that to be 1 over x to the positive 21 power. For g, recall from last class that when you have a product inside the parentheses, the exponent on the outside will apply by being multiplied to each of the exponents that are inside the parentheses since we have a product. And so this is now a to the negative 2 times 7, and then b to the 3 times 7 power. So this gives me a to the negative 14 power times b to the positive 21 power. And now, since the a to the negative 14 had the negative exponent, I need to flip that to the bottom of the fraction. So the b to the positive 21 stays where it is since it had a positive exponent. And now on the bottom, I have a to the positive 14 power. And that's my answer. Okay, for h, you need to recognize that the negative 2 is in parentheses right here where I'm pointing. And so when I apply this negative 2 exponent to both the negative 2 and the x to the 4, you keep the negative 2 that was the coefficient in parentheses, and it now has a power of negative 2. And then for the x, we have 4 times negative 2. So I have negative 2 to the negative 2 power times x to the negative 8 power. Both of those bases have negative exponents, and so I'm going to put both of them on the bottom of the fraction to where I now have 1 over negative 2 to the positive 2 power and x to the positive 8 power. You do have to simplify this coefficient since it is numeric. That negative 2 squared is negative 2 times negative 2, which simplifies to 1 over 4 x to the 8th power. And for example I, again, when you have a quotient inside parentheses with one exponent on the outside, that exponent applies to every base. So again, this is negative 6 in parentheses raised to a negative 3 power now, x raised to a negative 3 power. And on the bottom, y to 3 times negative 3 power. And so I have negative 6 raised to the negative 3 power times x to the negative 3 power all over y to the negative 9th power. Notice all three of the bases have negative exponents, so I'm going to flip which side of the fraction all of them are on. So on top now I have y with a positive 9 exponent, since it needed to flip to the top, and everything on the top needs to flip to the bottom. So on the bottom I have negative 6 now raised to a positive 3 power, and x raised to a positive 3 power. Our last step is to work out this negative 6 in parentheses to the 3rd power. So I'll do that off to the side here, that negative 6 quantity cubed is equivalent to negative 6 times negative 6 times negative 6. So the first two give me positive 36 times negative 6. And 36 times negative 6 is negative 216. You can work that off to the side if you want to confirm that. but that means that our final answer here is y to the 9th power over negative 216x cubed. Because again, you're allowed to have negative coefficients, just not negative exponents in your problem. That finishes up section 12.3 from our textbook. We are moving into section 12.4. I'm going to tell you now that I believe section 12.4 has more information than what I'm going to have in this video, because all you are responsible for scientific and decimal notation from this section is being able to convert back and forth. So you will not be asked any questions about scientific notation except being able to convert to scientific notation or convert from it to decimal notation. So that's what I have in this note here. You just have to convert back and forth between scientific notation and decimal notation. Going on and filling in your blanks here, we're talking in general here about scientific notation, that it is some m times 10 to the nth power, where that capital M is some decimal value that is between 1 and 10. And what you're filling in is that this is in decimal notation, and n is an integer. So remember the integers were both negative and positive, but they were whole values. So you next fill in the blanks here to write in standard decimal notation is that we are going to look and see the exponent first. And if it is a positive exponent, that's what we're filling in. When we look at the exponent, if it's positive, you will then move the decimal point that many places right for positive exponents. If when you look at the exponent, it was a negative exponent, you will then move the decimal point that many places left. So your questions will ask you to convert to standard or decimal notation. So I have this scientific form. I'm going to look at the exponent and see it is a positive 3. Since it is a positive 3, that means that I want to move 3 values right. So I had 2.04 to start with here. And when I move the decimal point 1, 2, 3 to the right, I have to put in a 0. And this means that I end in decimal notation with 2040. There's no more times 10 to some power in decimal or standard notation. For B, looking at the exponent, it's a positive 7, so that means I have to move the decimal point 7 to the right since it's positive. And so we start with 1.9902 for the first part of the scientific notation, and now we need to move that decimal point 7 to the right. 1, 2, 3, 4, 5, 6, 7. In all of those places that are blank counting, you fill in with zeros. And so we now have 199020000. And this is your answer. For C, looking at the exponent, it is a negative 4. So remember, for negative exponents, you need to move your decimal point left. So this means we need to move 4 to the left. So we started with 9.311 for our starting value in the scientific notation. When I move that decimal point 4 to the left, you go 1, 2, 3, 4, and place the decimal point. And that requires me to put in 3 zeros this time in those movements that I didn't have a digit for. And so our answer is the decimal point, then 0, 0, 0, 9, 3, 1, 1. Do not round in these problems. Just write out the whole set of digits. This last one looks a little weird in that all it has is 10 to an exponent power. But what that means is that in front of it, what's being multiplied is an implied 1. That we can write this as 1 times 10 to the negative 5. In any whole digit such as 1, the decimal point is always implied to be after the whole digit. And so now when we look at the exponent, which is a negative 5, that means we are going to move the decimal point 5 to the left. When we do that, remember we're starting with that 1 where the decimal is implied to be after it. And so when I move 5 left, I go 1, 2, 3, 4, 5 and place my decimal point. And I now have to fill in those spaces with my zeros. So your answer is the decimal point and then 4 zeros and a 1. And that is converting from scientific notation to decimal or standard notation is another way to ask it. Now, what we just did was generally considered the easier conversion. This next conversion is still simple in itself, but students tend to mix up if it's going to be a positive or a negative exponent. So you need to be really careful with these. So filling in your blanks to write in scientific notation, step number 1, okay, is that you're going to place the decimal point after the first non-zero digit. Non-zero digit. For step 2, count the number of places from the place decimal point that you moved and in which direction. So, if you moved right n places, okay, then put a positive n exponent on the 10. Another way that you can think of this is if you start with a large number, a number bigger than 1, okay, you'll end up with a positive exponent. So if I look ahead, if I'm using that idea, in answer or example A here, and example C, I have numbers that are bigger than 1 already to start with. So I'm going to say A and C should have positive exponents in their answer if I'm using that, and that would be correct. Whereas in B, if you moved left n places, then you put a negative n exponent on the 10. Or if it is a small number, smaller than 1 to start with, you should also have a negative exponent. So looking ahead, without even working it yet, example B and example D are decimal values that are smaller than 1. So they should have negative exponents, which would be correct. So for these examples of converting to scientific notation, starting in A, 125, our first step is to place our decimal point after the first non-zero digit, and you go from the left. So the first non-zero digit from the left is 1, so I place the digit or the decimal point in between the 1 and the 2. And so this is the first part of my scientific notation. That's now 1.25 times 10, and all I have left to do is figure out what the value of the exponent is. And so I want to see, to get from the placed 1.25 back to 125, I have to move that placed decimal 2 units right to get back to where it started. So if I went 2 to the right, remember right means that I need to have a positive 2 for my exponent. And so I put the positive 2 for the exponent of the 10. And this is your answer now for scientific notation. Remember, you can always reconvert your answer to check that you got it correct. So if you thought that converting from scientific to decimal was easier, then check this answer to see if we got it right. That we have a positive 2 exponent on the 10, which means that I need to move the decimal 2 to the right. So if I move this decimal 1, 2 to the right, I get 125, which notice that is exactly what we started with in A. And that's how you know that you got it right, is if it rechecks out. For example B, okay, we want to place the decimal point after the first non-zero digit. So there's zeros in B, but we place it after the first non-zero digit, which is the 2 here. So in between the 2's. So the start of our answer is 2.2 times 10, and now we need to know what the exponent is. So from the placed decimal back to where we started, I have to count out and go 1, 2 to the left this time, from the placement to where it started. And if I went 2 to the left, that means that I should have a negative 2 for the exponent. So this is 2.2 times 10 to the negative 2 power. And that is your answer for the scientific notation for part B. For C, 3042, we are first going to place the decimal point after the 3 and before the 0. And now, to figure out the end of this 3.042 times 10, we need to figure out that exponent value. And so we count that to get back to the original, we have to go 1, 2, 3 to the right. And if we went 3 to the right, that is a positive 3 exponent. So we have a positive 3 on our exponent for the 10. That is our answer for C. For D, there's a lot of zeros, but remember that you place your decimal point after the first non-zero digit from the left, so between the 4 and the 5 in this case. So the start of the answer for D is 4.53 times 10. And now we figure out that exponent. So to go from where we placed the decimal back to where it started, we have to go 1, 2, 3, 4, 5, 6 to the left. And if we went 6 steps to the left, that is a negative 6 exponent. So 4.53 times 10 to the negative 6 is your answer for D. That finishes up section 12.4. That's all you're required for in 12.4. Now I have to warn you, section 12.5 has a lot of vocabulary information. Now, since we're doing fill in the blank notes, that will not take as long as if we had to write them on the board. So hopefully that won't be as bad for you, but you will have to know all of these terms and be able to identify what they mean and then be able to identify components of them in an example. And I'll show you what that means. So we're going to have more filling in the blank in this section. So section 12.5, we're going to be talking about polynomials, but we start out small with just the basics of monomials, and we define bigger information after that. So what monomials are, filling in the blank, is that these are single terms. That means there's no addition or subtraction, and they are of the form a, so some coefficient value, times x raised to some n power exponent. And there are no negative exponents and no division of variables for something to be considered a monomial. So good examples are things like 6 times x, it's a single term, no addition, subtraction, no negative exponents, no division of variables. Negative 3x squared, because it's okay for the coefficient to be negative as long as the exponent is positive. 10 is good because it is just a numeric value, and the base has an implied exponent of 0. So we just have 10, and you can continue on listing those. But your next fill in the blank is actually the vocabulary word itself. The next one is polynomials. Root words, monomials, mono means single or one. Polynomials, poly means many. And so the definition for polynomials is the addition and subtraction of multiple monomials. So examples, good examples, are this first line. I have 6x plus 9. They're added together. They're a polynomial. This next one happens to have 1, 2, 3, 4, 5 individual terms. And each individual term is a monomial. And so altogether that makes a polynomial. But non-examples in the second line here, the reason why 5x cubed plus 2x to the negative fourth is not a polynomial is because of this negative 4 exponent. That means that individually that term is not a monomial since we cannot have any negative exponents. So overall it means the whole value is not a polynomial. For the 1 over x plus 8, we have this division of an x of a variable, and that is also something that you cannot have, no division of variables in monomials. And we could continue on with more examples. But your vocabulary that you are responsible for knowing, we're going to start out with the word terms that we've talked about in the past. What these are monomials that are separated by a plus or a minus, and you need to include the signs, positive or negative, when naming terms. Okay. Like terms we've talked about in the past, and these are terms that have two characteristics that they have to fulfill. The first one is that the terms have to have the same variable. And the second thing is they have to have the same exponent. So if we look at these examples, 3x and 2x are considered like terms because they each have a matching x, with the x's each have an implied exponent of 1. 9 and 7 are considered like terms because they match in the sense that they have no variables, and that matches. 3x squared and 7x squared are like terms because the x's, the variables, match, and the exponents 2 and 2 match. So, real-life application of those children's matching games right here, like terms. Non-examples, 4 and 7x are not like terms because notice 7 has a variable of x and 4 has no variable, so they do not match, not like terms. 3x and 8y are not like terms because the two variables are not the same. X and y do not match. 3x cubed and 8x to the fourth are not like terms because x cubed has an exponent of 3 and x to the fourth has an exponent of 4. Even though they have the same x as their variable, they do not have the same exponent, and so they are not considered like terms. Moving on with vocabulary, coefficients. These are the numbers in front of the variables and the constants. Degree is the exponent value of the variable. Degree of the polynomial is the highest exponent value in the polynomial. Descending order, and you're going to be asked to do descending order in a lot of different problems, not just to identify it, but at the end of a problem to make sure your answers are in descending order. So I put a star there. is that descending order is writing the polynomials when the degrees are written in order of biggest on the left to smallest on the right. Ascending order is writing the polynomials when the degrees are written in order of smallest on the left to biggest on the right. So descending order and ascending order are opposite directions. Monomial we defined above, but I'm bringing it back here just to contrast with the next two vocabulary words. So what we're contrasting here is number of terms. So a monomial is a polynomial with only one term. Binomial, bi means two, is a polynomial with only two terms. Trinomial, tri means three, so trinomial is a polynomial with only three terms. Okay, now you're going to get into what type of question I can ask you with all of the above vocabulary. So you have to understand the above vocabulary to then answer these next questions. Unfortunately, the page cut off, and so we're going to be referencing this polynomial that I give you at the bottom of this page for the A and B on the current page, but also for C, D, and E that continue on the next page. So for the polynomial negative 4x to the fifth plus 6x squared plus x minus 6, A asks us to identify the terms, which means list or write them out. And so I'm going to notice that to separate the terms, we look at these divisions where we have pluses and minuses to separate out. So those are our separations, which means we have 1, 2, 3, 4 terms. And remember, when listing the terms, you do include the signs. So the first term was negative 4x to the fifth. When listing terms, you need to have commas. So we have a comma. That's what distinguishes it from just the polynomial itself. The second term was positive 6x squared, and the positives are implied even if you don't put a plus, so that's fine. Comma. The third term is just x, comma, and the fourth term includes that sign of negative 6. So that's your answer to A. Now, looking at these individual terms, you're asked to identify the coefficient. So that means the number in front of the variable or the constant. And so for the first term, the number in front of the variable is negative 4. That's the first coefficient. The second one, the number in front of the variable is 6. The third term there, it's not written, but in front of that x is an implied 1. And so that is our coefficient of 1 for part B. And remember that you also include the constant value in your coefficient. So we do include negative 6 in our list. Now I'm going to have to flip over. I'll write this polynomial at the top of the next fill in the blank page, which maybe that will help you as well in filling these in. So we're referring to the polynomial from the previous page that was negative 4x to the fifth plus 6x squared plus x minus 6 to finish answering these questions. And so C asks us to identify the degree of each term. Degree are the exponents. So we have an exponent of 5, of 2. For this term that is just x, remember that has an implied exponent of 1, even though it's not written. And so you have an exponent of 1. And then this minus 6 term, it's not written, but it has an implied x with a 0 exponent for any constant term. Because remember, x to the 0, it re-reduces out to just times 1. So 1 times negative 6 is just back to the negative 6. But for the degree, we do have to include that degree of 0. Some students like to remember that by saying if there was no x there, just negative 6, that means a 0 is included in the degrees. Now, the degree of the polynomial is always the highest degree that was listed in the step above. And so 5 is our highest degree. That's the overall degree of the polynomial. E is the polynomial written in ascending or descending order. Since we go from highest on the left, 5, and then down 2, 1, 0 to smallest on the right, then this is descending order. And F is the polynomial a monomial, binomial, trinomial, or none of these? We had 1, 2, 3, 4 terms. 4 terms does not fit into the 3 defined ones that we have. So for this one, it is none of these since there are 4 terms. The next example, state the degree of the polynomial and whether it is a monomial, binomial, or trinomial. So for this one, all you're doing is looking for the highest exponent value for degree of the polynomial. So in A, we have an exponent of 5, 2, and an implied 0. And so our highest exponent value is 5. So for A, the degree of the polynomial is 5. And there are 1, 2, 3 terms. So for 3 terms, our answer is a trinomial. B, they're trying to trick you here. The highest degree is not the first one. They're just going to see if you pick the first one. But notice the highest degree, 3 and 4, is the second, is 4. And so the degree of the polynomial for B is 4. And then looking at this, we have 1, 2 terms. And so for 2 terms, this is a binomial. The next example, we have collected or combined like terms in the past. This is something that you should have done in Prep 1. So we're just going to do one example to review that. And then what is new is that you do need to answer in descending order for your final answer. You can have it in non-descending order in the middle in your work, that's fine, but your final boxed answer does need to be in descending order. And so for this example, 7x squared is a like term with 5x squared. And negative 3x matches negative 9x. Remember, we're looking at variables and exponents. So if I just rearrange to put them next to each other, this is 7x squared plus 5x squared, and then minus 3x minus 9x. Now, I still have to finish to actually combine those to single terms. That 7x squared plus 5x squared, remember, when we add, we just add the coefficients. 7 plus 5 is 12, and we keep the like term the same of x squared. Do not say that's x to the fourth. You do not change exponents when you add. And so over here we have negative 3 minus 9. That is negative 12. And we keep the like term of x the same. Since 12x squared is not a like term with minus 12x, since they have different exponents, you cannot combine further. And so this is your final answer. The last couple topics in this section, 12.5, are adding and subtracting polynomials. Really what that is a review of distributing and combining like terms. Students tend to like these sections in my classes since it is mostly review for them. And so just quickly reminding you of a few things. If you are adding polynomials, what that means is there's going to be a plus sign in between parentheses. If there is only a plus sign for your fill in the blank, if there's only a plus sign in front of the two parentheses of polynomials, then you can distribute the implied positive 1, which effectively means you can just drop the parentheses, but only if it's a plus. And then combine like terms. So for these examples, part A, notice it's just a plus or an implied plus or positive for A. And so what happens is that you do have these implied positive ones that if you want to go through the step of showing just for yourself that we're distributing implied positive ones, you now have 1 times 2x is 2x. 1 times minus 12 is minus 12. 1 times negative 3x is minus 3x. And positive 1 times positive 22 is plus 22. So effectively, notice all it did was drop the parentheses, which is what you're allowed to do when you're adding. It will change when we're subtracting. And so now we're going to combine like terms. Notice I have 2x and minus 3x are like terms. So 2 minus 3 gives me a negative 1, and I keep that like term of x the same. And then negative 12 is a like term with positive 22. So negative 12 plus 22 is plus 10. And negative 1x plus 10 are not like terms, so that's our answer. For B, okay, notice it's a plus in between them, and so if y'all are okay, I'm just going to go ahead and drop those parentheses, that this is 5x squared minus 3x minus 6 plus 2x squared minus 8x minus 3. And now all we have left to do is combine the like terms. So I have 5x squared matches 2x squared. So 5 plus 2 gives me 7, and then I keep the x squareds. Next I have like terms are the x's, negative 3x and negative 8x. So minus 3 minus 8 is minus 11, and keep the x's. And the last set of like terms are the constants, minus 6 and minus 3. So minus 6 minus 3 gives minus 9. And now notice 7x squared minus 11x minus 9. There's no more like terms in common, and so that is our answer. This next one I wanted to show you because there are fractions, and I know that y'all do not like fractions. So I just want to double check, make sure that you understand how to do this with fractions. So the fact that there's a plus in between means that we can drop those parentheses. So we have 3/4 x squared minus 1/3 x minus 12 minus 1/3 x squared plus 2/9 x plus 3. Now, though, I've kind of been skipping the step of writing the like terms next to each other, just kind of using the underlining to identify them. But since we have fractions, I'm actually going to take that step to write them together. So for the x squareds here, I have 3/4 x squared minus 1/3 x squared. For the x's, I have minus 1/3 x and plus 2/9 x. And for the constants, there's negative 12 and plus 3. Notice that you have to move the sign with the number it's in front of. So always move the sign positive or negative with the number it's in front of, not the position in the expression here. And so finishing this problem, if I want to combine these x squareds, notice I'm going to be doing 3/4 minus 1/3. And so for fractions, you have to have an LCD. So for 4 and 3 in the denominator, your LCD will be 12. So to get 12 in the bottom of both of those fractions, for the first one, since 4 is in the bottom, I'll need to multiply by 3/3. And so that will give me 9/12 x squared. And the second fraction, to get 12 in the bottom, I have to multiply top and bottom by 4 over 4, since the bottom has 3 at the moment, and 3 times 4 will make 12. So that gives me minus 4 over 12x squared. For the next set, the x's, the denominators are 3 and 9, and so their LCD will be 9. For the first fraction to get 9 in the bottom, I need to multiply the bottom by 3, so the top by 3 as well. And so that gives me minus 3 over 9x. And the second fraction was nice enough that it already had the denominator of 9, and so we have plus 2/9 x that we just bring down. And then I have minus 12 and plus 3. Since they're whole numbers, they don't need a common denominator since it's already an implied 1. And now we go ahead and combine the like terms. We only needed common denominators for the sets of like terms. And so we have 9/12 minus 4/12 gives us 5/12 x squared. Negative 3/9 plus 2/9 keep the 9 in the bottom. And minus 3 plus 2 gives us minus 1. So minus 1/9 x. And then negative 12 plus 3 is minus 9. There are no more like terms, so that is our answer. Okay, almost done. Filling in this next blank here, okay, if there is a negative sign, negative. So we just did adding and positive signs, now we're looking at negative. So if there's a negative sign in front of parentheses of polynomials, then you need to distribute the negative 1 inside the parentheses, which changes all the signs to the opposite sign. So part A here has a negative on outside parentheses and just one term. So it is an implied negative 1 even though it's not written. And so we do negative 1 times negative 5x squared, which all negative 1 does is multiplying negative 1 will change the sign. So negative times a negative is now a positive 5x squared. Part B, we're distributing again that implied negative 1 inside to both terms now in the parentheses. And so you'll now have negative 1x squared minus 6x. It just changes those signs. All your work is for these problems is to show these little arrows. And for part C, distributing that implied negative 1 now to 3 terms, all it's going to do is change those signs again. So we now have negative 8x cubed plus 2x and minus 1. Notice you also do not have parentheses in your final answer. So this gets us ready and leads us into subtracting polynomials. So this is the key difference from the adding that we just did. When subtracting polynomials, this is so important. You first distribute. First distribute the negative 1, which is implied by the minus symbol that you can see in between the sets of parentheses here in A and B. So first distribute the negative 1 throughout the second polynomial, then drop the parentheses and combine like terms. So if you do not distribute that negative, you're going to end up mixing up some of the signs and then messing up your answer. So our first step, since we see this negative symbol in between the parentheses, is that it is an implied negative 1, and we're going to distribute that negative 1 to that second parentheses. The first parentheses has a positive 1 implied in front of it, and from the adding section that we just did, we know that means that we can just drop that parentheses. And so dropping the first parentheses gives us 4x minus 8, but then distributing the -1 to the second parentheses changes the signs in the second parentheses. So -1 times 3x is now minus 3x, and -1 times -4 is plus 4. Now you can combine any like terms. And so for the x's, we have 4x and minus 3x. 4 minus 3 gives us 1x, or just x. And then minus 8 and positive 4 are like terms. So these are our sets of like terms. Minus 8 plus 4 is minus 4. And then x minus 4 cannot be combined further. You can just write that as x minus 4. But that is your answer. For part B, again, notice it's a minus in the middle, so you cannot just drop the parentheses until you distribute that -1 to everything in the second parentheses, every term. We can drop the parentheses for the first since it has an implied positive 1. So we have 6x cubed plus 5x squared minus 3. And now we distribute that -1 to change all the signs in the second parentheses. So we now have plus 2x cubed minus 3x squared plus x minus 1 with no more parentheses. And now we just need to combine the like terms. We should have these in descending order, which is kind of what I've been doing for you as I go along, but you need to make sure that you consciously think about having your answers in descending order. So descending order, we'll look at those x cubes first as the highest degree. So 6x cubed plus 2x cubed, 6 plus 2, gives 8 for the x cubes. 5x squared minus 3x squared, 5 minus 3 is positive 2 for the x squareds. Next is the x's. Notice there's only one x, so there's nobody that the x can combine with since there's no other like terms. So it doesn't change, but you do have to still have it in your answer of plus x. And then minus 3 and minus 1 are like terms. So minus 3 minus 1 gives minus 4. So we have 8x cubed plus 2x squared plus x minus 4. And there's no more like terms of those 4. And so they are in descending order, 3, 2, 1, 0. That is our answer. One thing I have in this little star here is that you need to look to see if there is a sign and what that sign is between the parentheses for what it's telling you to do. So notice like here in A and B we had minus signs in between, so that means you are subtracting. Whereas on the previous page we had pluses in between the parentheses, and that's how we knew we were adding. In the next sections we'll get to multiplying and dividing. But all of your instructions will say simplify, not add, subtract, multiply, or divide. And so when it says simplify, that sign tells you what operation you should be doing. That finishes up section 12.5. You can now go online and do your homework in the Connect Math for sections 12.3 to 12.5. And you can also now do the attached section 12.3 to 12.5 quiz that I gave you along with this fill in the blank notes section and that I emailed out to y'all. Okay, again, if you have any questions on this material, you can email me. I just may not be getting to my emails very quickly since I'm out of town. You can also go to the Fort Walton Beach Campus Math Lab, room 702, and you can talk to any of the Math Lab tutors in person, and they can help you out with any questions that you have. Okay, make sure that you also on Friday or any time before our next class that we meet in person that you also watch the next video that will be going over sections 12.6 and 12.7. I hope you have a good day. Bye.